Okay.
Great.
So shall we start?
Yes.
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 Thank you all for joining this session. This is SCC1, which is the ICWS and SCC joint panel on new forms of services and new approaches of serviceology. This should be really a substantive and fun panel in spite of the various time zones that we're all joining in. My name is Kumar Bhaskaran. I'm with IBM. Professor Shafei Shu and myself as co-chairs for this session would very much like to extend a very warm welcome to everyone who has joined online and also to those folks who are going to be accessing this via the video playback. Services and service systems are as diverse as human concerns are. Environment and climate change, healthcare and life sciences, supply chain and e-commerce, agriculture, and sustainable food development, to name a few. It's such a broad range of applications for services and service systems, which is why they are incredibly important. And we also see there is an expanding instrumentation of both the physical world and the digital world that is allowing us to acquire data, analyze it, and also share it. And that is spawning open innovation in service computing. And meanwhile, R&D in academia and industry is advancing and proliferating an alphabet soup of technologies, both new as well as old, that are driving innovation in services. So lots going on in services and service computing. So we have brought together a distinguished panel to really sort this out for us, to make sense out of it and help us see, have some clarity in the R&D directions. That's what we hope to achieve here. So let me briefly introduce the panelists in the order in which they would speak. So after the panelists present their point of view, we'll have a Q&A. For those who have joined this session, please don't hesitate. Ask your questions in the chat and we'll include them in the Q&A as well. So first, my session co-chair here is Professor Shafei Shu. He's the professor of computer science at Harbin Institute of Technology. He's also the president of the institute at Weihai campus. He's a passionate educator and an accomplished research scientist in services computing. It's very fitting that he is the session co-chair for this important panel. Second, we have Dr. Rong N. Chang. He is the general co-chair for the Congress, general chair for the Congress for IEEE Services 2021. He's a principal research scientist at IBM Research, and he actually leads the Future of Computing platform and services for regulated industries for IBM worldwide. Rong, thank you for being part of this panel. Then we have Professor Atman Bukwitaya. He is the professor of computer science and head of computer science at University of Sydney. And his team and himself has been advancing R&D in services computing. And I like the way he puts it, that makes things faster, better, and more effective. So that's really cool. And then we have, after Professor Atman, Professor Shahram Dastar, and he is a professor of computer science at TU Wien. And he's also the head of research of distributed systems. And Professor Shahram has been putting a number of different things together: human beings, things, software, AI, in the evolution of distributed systems, which are extremely germane for service computing. And then we have our final panelist, Professor Feng Zhiyong. He is actually a professor in the College of Intelligence and Computing at Tianjin University. And he is also the chief scientist of several national key R&D projects in China. And he's a leader in services computing and services ecosystem. So we'll hear from all the distinguished panelists. Now I want to actually invite Professor Xiaofei to set the stage for the panel in introducing the main themes and present his point of view.
Okay, so thank you, Kumar. Yeah, so may I share my screen? Yeah, so let me share. This one. Sorry, let's wait a moment. So do you see my screen? No?
See your chat window.
We are seeing a chat window at the moment.
Yeah, not your PowerPoint presentation. You probably want to share your whole screen.
So now can you see?
We only see your WeChat. I think that's your WeChat window now.
This one?
Yes.
Yes.
Yeah. So
see
my picture.
Presentation mode. Yeah.
Okay. No. Yeah. So
yes.
Okay. So take some time to adapt to the scale. Yeah. So, ladies and gentlemen, it's my pleasure, to be the co-chair of this panel with Kumar together. So, I would like to explain, the reason, so why we organize this panel, and then present my idea, my focus on education. So, I think, we think, so. Recently, so we can find some new trends of services, especially in new forms and new approaches. We would like to have a look on the new driven force or insight of the insights of the new forms and new approaches. Then we can talk about the new education programs. So if we think about the new driving force on services and serviceology, we can consider the technical issue, including the new information technology like A, B, C, D, E, F, G, IQ, and more. And we can also think about we can see that the driving force from the new development of industry, economy, and society. So like service industry transformation, service-oriented manufacturing, and cross-field business servitization. And if we look at the economy, so we can see the digital economy develop strong and strong. And we can also see the service-based economy and service ecosystem. The society also get into the service-oriented society. This is our view. And in such kind of environment, so we can see more new forms of services. Like software-defined services. So tomorrow I will talk about service-defined software. So change the way. So so like cloud services, microservices, mobile app services, and blockchain-based services. We can also have integrated hardware and software services like IoT services, AAG services, 6G, 5G services, and quantum services, and so on. And if we get higher, we can find the new forms of composed services like big services, crossover services, complicated cognitive services, and internet plus services, or service plus X. the challenges, the new challenges, how can we explore the hyper-convergence of new technologies and new approaches for innovation in XaaS and enabling these new forms of services. And then, so if we think about the new approach to create or produce services, we can have new technologies and a new way to integrate the multi-role based crowdsourcing approaches for creating or producing services by multi-layer users, stakeholders, for multi-worlds, network sources, domains, sectors, and so on. And we need also have a new methodology to propose the new service methodology to adapt to the new forms and new transformation and situation of new services. Then we face to the new challenge here is that how to drive the evolution of infrastructure, platform, SaaS and XaaS by means of collaborative intelligence, human intelligence and artificial intelligence, zero trust, cyber secure digital fabric, and crowdsourcing and microservice driven API economies. So this. And then, so we consider the new form and new approach. We should also consider the new education. Especially Ron suggests strongly we need to talk in this panel about the education issue. Because in the past more than 10 years, past decades, so I pay a lot of attention and energy in the educational job on Serviceology and service science and engineering education. So if we talk about Serviceology, so last year in a plenary panel, we talk about Serviceology. In fact, 12 years ago, so we create this words, 12 even earlier, so this words Serviceology. We consider the Serviceology as a transdisciplinary scientific foundation for modern digital services and service-oriented social technical ecosystem. And to develop the educational program on service science and engineering or Serviceology, the purpose is to develop this such kind of education program for the future domain service industry and future service-oriented economy. In fact, if we think about how can we set up the framework of the interdiscipline education, we think that we need to cover several disciplines like information technology and engineering, management science, social science, and requirement engineering, and more. And generally say, so the Serviceology cover this topic, this scope, for example, service science, service engineering, service management, service enabling technology, and transdisciplinary frontiers for services. And several years ago in China, so we in the scope of software engineering, we discussed about how can we develop an extension of software engineering. One direction was software service engineering. I am also one of the director of the China Ministry of Education University Teaching Steering Committee on software engineering. So in this committee, we have presented knowledge body of software service engineering. So this knowledge body cover 5 knowledge fields, knowledge areas. One is the service architecture and the design, including service-oriented software architecture, requirement engineering, software service design methodology, software service construction and configuration. The second field is software service enabling technology, cover the foundation of service computing, of software service technology, and the environment of software service operation, and the quality issue, and quality assurance and security of services. And the third domain, so cover service business analysis, including service business process and modeling analysis, service business process integration, service business performance management and operation. And then, so the next knowledge area is service management. This is a cross-disciplinary area. So including service forms and management, service innovation design, from the business level, and service value theory and service credit systems, And then so we also cover the service application and practice, including manufacturing services and production services, social services and life services, and especially we focus on, we emphasize again the social, local, and mobile, the active service application and domains. And based on this kind of knowledge body and structure, so we have developed the program on service science and engineering in our university, Harbin Institute of Technology. In fact, we have set up such kind of program 3 times. So the earliest was the first batch was collaboration with IBM in 2007. And then so second batch was 2010. We organized the second program, and then 4 years ago we set up the major of service science and engineering and admitted by the Ministry of Education. This is the first program of service science and engineering in China, in Chinese universities. So we focus on demand of modern service industry and service society. So we would like to cultivate the comprehensive service elites and professionals through the multidiscipline fields, the comprehensive education and university industry cooperation. In fact, last year, the first class of the undergraduate students in this program in our university, they have already graduated. And this program, in this program, we covered computer science, software engineering, management science, economics, and social science. We also set up a very good collaboration relationship with big companies. So in service sectors, service industry sectors. So this is the story. And then so so this is my idea. So later on, I would like to discuss with you about this topic, especially on education issues. Okay. So then, so next turn would be Dr. Zhang Rong.
Okay. Thank you, Professor Shi. And I'm honored to be on this panel to share with my view on new ways of programming the service systems. And I'm a computer science and engineering major. So I've been enjoying being an experimental computer scientist. So I can say that even though as Xiaofei have been put, we have been seeing a lot of technology have been advanced in recent years, right? And making writing the distributed systems and service easier, but it's like writing a assembly code on a faulty hardware, if you like, even in the cloud environment. So I think I still miss the old days when we learned the programming languages that we can write programs based on a well-defined computing model with a well-designed language construct. Then the only thing I need to do is just compile and let it run. The rest of the detail will be handled by the system. So what I think what we are missing right now is really saying we need to help that people to create the cloud-based services, really like writing a high-level language rather than the way we writing today. There's so much details that require a lot of technology knowledge, know-how, and management. it's getting very, very impossible to get things done well. So especially for the enterprise computing environment, it's not just the functional capabilities of the application that we are familiar with in the old days. We just read a program running on a machine. It's actually requires things like operation support services and business support services together with the functional code together, because when people consume the services, they are consuming in the runtime operations environment. It's not just running a piece of code on someone's machine. So that makes kind of enterprise services applications become a challenging to get it cost effective and cost efficient. Even though the older technology promise agile business capabilities, I think that's a big gap, and still have a lot of room for innovative researchers work. Now, in practice today, as we know well, we are many companies in the world actually is facing the lack of skill issues in their employee portfolio, because hiring, retaining the full stack DevOps expertise with with knowledge on what the service management is about is not easy, and it requires a lot of learning, a lot of practice, a lot of coding, and a lot of kind of experiences. So what I'm thinking right now, the thing I'm talking about is really say, how can we somehow focus on the research on the high level distributed programming languages that facilitate exploiting composable and managed microservices as needed, and that services, that's what we need. Then the reason why I talk about microservices, essentially, especially the managed microservice, means that now we suddenly have a fundamental construct that we can partition the complexity of the overall service system into individual managed microservices. But then we still need a lot of kind of technologies and the experiences on how to compose them into another high-level managed composable microservices. I think that's a major thing. That will lay a solid foundation for the high-level programming languages for programming distributed services. So this is my thing. Okay, so that's the end of my opening statement. I will pass the floor to Osman.
Thank you, Ron.
Okay, I'm going to share. Okay. Give me 1 second. I'm going to share the screen. Hold on a second. All right, sharing the screen. Can you see the screen? Presentation mode?
Yes.
Yes, we can see.
Okay, great. Excellent. Thank you very much. And I'm really honored and privileged to be part of this panel of distinguished colleagues. So I'm going to be talking about the new forms of services, that is from my perspective. So I'm going to focus on two types of services that I think present a lot of opportunities for a big impact of service computing, and that is the area of IoT and of course drones. So what do I mean by that? So when I talk about IoT, the Internet of Things, I think everybody is familiar with what that is, but to me it's really how we can leverage the fact that now we have things that are internet connected, and I would like to be able to use them in ways that we have never anticipated. Okay, and I think that adding the service on top of IoT would almost like be adding the web to the internet. So the internet was about connecting machines, right? And the web really made the internet valuable. So what I'm proposing is that if we put the service on top of IoT, we would be achieving the same type of impact of IoT. And of course, drones. Drones are everywhere, and they're being used for a range of applications. And I think, again, using the service to be able to really innovate on how we use drones would open also a lot of opportunities. But let me focus on IoT for the moment, and I'm more than happy to answer any question about drones. So more specifically, let's look at IoT services in smart cities. So where everything, as I said, is internet connected, and the idea is how we can leverage all these things to provide basically convenience and efficiency. Because the word smart usually is about convenience and efficiency. When I say efficiency, it could be efficiency in terms of how we use water, how we use electricity, gas, and the likes, right? And convenience is about actually not having to make efforts for things to happen. So almost reading our minds and things being ready for us. So let's look at one type of a service that my team has looked into, and I think has a lot of potential in terms of impact. One thing that all of us need, doesn't matter where we are, where we live, where we come from, is energy. Everybody needs energy. The thing is that we all have had issues in terms of connectivity. That is, having to be tethered, so always finding a PowerPoint, or like at a coffee place with browsing, our phone or laptop or tablets actually die on us, and we need to do work. So the idea there is that with the shared economy and crowdsourcing, why not share energy? That is, if I have spare energy, why don't we share it with others? And we want to servitize that. So that is servitizing the concept of sharing energy among people. So if you are at a coffee shop and you would like to be able to browse the internet, you don't want to worry whether actually you have enough energy to do whatever you want to do, because you know that actually somebody sitting next to you may actually wirelessly give you energy. But then you have to have a whole infrastructure, right? That whether it's about security, about selection, about composition, about all the things that we know in service computing, that actually is, again, adding the service as a high-level abstraction to then be able share energy in a seamless way, wherever we go, whether it's in the classroom, whether it's in hospitality, or any other setting. So, and I think the service paradigm would have a tremendous impact on those applications. So I'm going to stick to my time. I was given 5 minutes, so I'm going to stick so I'm going to hand it over to Sharon. So I'm going to stop sharing.
Okay. So I'm sharing my screen. Can you see it now?
We are waiting for it to come. Yeah.
Yes.
We can see it now.
Okay. So my internet connection is pretty unstable. So you can see it?
Yes.
Okay, perfect. Yep. So yeah, for me, it's also a great pleasure to be in this panel, a great privilege. I selected a topic which I'm working on since a couple of years, which is related to edge intelligence. But in fact, it's actually not only edge, but it's looking at the whole continuum of computing. And this is what I will talk about, and you will better understand it in a minute. So when we look at the different perspectives on distributed systems infrastructure in general, we can distinguish between two different views. One is the cloud-centric perspective, which was actually enabled by service-oriented computing, which now emerged as the actual mainstream technology. So the cloud is in the center of things. Everything is connected to the cloud. So the edge is connected to the cloud. The things are connected to the cloud, etc. The other perspective would be the internet-centric perspective, where basically the internet is the main thing and all the other technologies are connecting with each other through the internet. And of course, to create a resilient infrastructure, this would be needed to make progress. So I give you an example of where I think that the dynamic evolution of this infrastructure has to go. So consider like the COVID pandemic that we have now, where we have different domains of systems, like we want to track the quality of the healthcare situation. We would like to see the mobility of the people. We would like to have access to hospital data, etc. So in fact, it's a new mixing and matching of horizontal and vertical domains of things that we did not have in the past, and we could not even conceive in the past, right? So this should be something that is possible with a service-oriented, let's say, approach or mindset, so that we are able to put these things together in a flexible way so that we get real IoT data, not just simulations of some politicians or some scientists, but actually real data. Combine that with the real mobility data, combine that with real healthcare data, etc. So this is where I see that we need to make progress in the dynamic evolution of infrastructures. So for that purpose, actually, we have to look at the whole computing continuum, as I call it. So we have to understand that everything goes from, from the IoT devices on the left-hand side, which have low reliability, they are highly volatile, they're mobile, we have battery constraints, as Atman was mentioning. They are controlled by users, maybe by service providers. We move to the right, we can see that we have edge providers. Edge providers can be telco operated, but could also be provided by companies, even by individuals. Further to the right, we can have fog providers, which are typically telco base stations. Applications can be residing on there. And we have the cloud domain on the right-hand side with virtually unlimited compute and storage resources, the full spectrum of cloud services, high availability, lower cost, high latency, etc., which are provided by the cloud providers. So essentially, my argument is that if we want to make a good progress for the next century, the next decade, let's say, we need to look at this exercise as a compute continuum. So basically, how do we master the way to write applications, deploy and manage the applications across the whole spectrum? So in other words, which parts of the services reside on the IoT, which reside on the edge, on the fog, and on the cloud? How do we do that? Do we do that manually? So we basically write some code to say, okay, this has to be running on one edge device or on this base station or on that cloud. That obviously is not very helpful. Ron was actually mentioning this kind of, we don't want to write assembly code for each piece of hardware which is out there, right? So we want to be able to define the way that we would like our system to behave and to operate, but we would like to have higher intelligence on the infrastructure. And this is where our research is focusing on, basically how to actually deploy, manage, and govern the services which are being executed on these different parts of this overall compute continuum. Thanks very much.
Thank you, Sharon.
Hello. I want to talk about the service ecosystem, society, and the challenge. As a bridge between intelligent elements and the end user, service give a unified description logic to everything in smart society. It operates that service play a very important role of the connector in operation of smart society, making the collaboration and the integration of the cross-border element truly possible. The entire society has gradually evolved to be an ecosystem of mutual dependence and benefit. Its evolution is driven by technological innovation, with energy works vitally between nations. Service ecosystem is intersection of business, technology, and social computing. It has the characteristics of the complex adaptive system. These characteristics bring whole challenge to its operation and optimization management. On one hand, smart service has duality characteristics such as security of personal privacy, defect of machine intelligence, potential risk of technological governance, and so on. On the other hand, the complex relationship between smart service magnify these potential risks. The complexity often makes us only see tree, but the forest. We need a new display that can integrate insight from interdisciplinary service ecosystem can be reviewed the full picture and evolution law of smart society. This slide shows the change from traditional service to new service ecosystem. Service provider become service network, service requester become service social network, and service registry become value network. So the service ecosystems consist of three component network, social network. The social environment are important factor influence the implementation of smart service, including population, law, culture, and industry, especially coordination of interests among government, enterprise, and citizen. Service network. Various types of service basically coexist in cyberspace, including human intelligence service, machine intelligence service, and human machine coordination service. Value network. As a transaction media, the value cycle connects various roles. The operation of service ecosystem consists of three things: everything as service. All kinds of online and offline resources are virtually and published in the form of services. Through their interconnection, it's possible to create various virtual organizations as well as redefine the various public affairs. Service as a commodity. The service matching between provision and demand can be finished in a service marketplace, just like a commodity transaction. In the end, such a value circulation can be formed, include value creation, realization, and distribution. Value as a coordinator. Value network acts as a mediator between service network and social network. It can promote, adjust, and evolution the social network and the service network. In the end, the service network changes into a hierarchical structure similar to natural ecology, include individual, population, and community. Service ecosystem is an interdisciplinary product which involves software architecture, social network, complex dynamic system, and so on. The observation perspective also extends from the service and its register to complex network composed of service and user groups. The form the similar technical field to the value exchange in the social field. That's my presentation. Thank you for listening.
Yeah, thank you. Thanks to all the panelists. We've gone through their points of view. Now we get into the Q&A part of it. Let me shared the wrong one. Let me share the screen here. Must be a way to share the desktop, no? Yeah. So we've gone through quite an interesting set of points of view, and we're going to get into the Q&A to just sort of dig deeper into some of these meatier issues. I would invite the audience also to, put in your questions during the chat as we get into the discussions here. So, one thing I have seen, I've got some specific questions for each of the panelists to get us started. And then there are some cross-cutting themes as well, as each of you had presented your points of view. So I have a question first to, Professor Atman. It was very interesting to see the IoT and drone services, and as Professor Sharam was talking about the edge intelligence, clearly these devices would have to have some distributed intelligence as well. And there'll be a lot of machine-to-machine communication between them. And you touched on, and you alluded to this idea of this next generation sort of internet of services as well. Why do you think the service paradigm is so very well suited for advancing these technologies and applying them in a responsible way?
That's an excellent question, Kumar. So let me just pick one, and that is drones. So the technology in itself is widespread. We have, drones are cheap, they're available. The problem is that we really haven't scratched the surface of how we could use them effectively. And to me, it's actually the abstraction is how we could use, swarms of drones, like for instance, when we talk about delivery services, okay? What it is right now, if you look at all the projects that are out there, they usually is point to point. So, if you take something from the warehouse and you deliver it to a destination. But there is no really a formal approach of how you could use your set of drones in a city, say like Sydney here, where now it's not an if, it's when people would be ordering their pizza at midnight, and that would be actually a drone would take it from your Pizza Hut or Domino's to the place. But not only that, they may actually have multiple pizzas, right? That actually is scattered around the city. How would you do that? And to me, it's just look at the service paradigm and you say, really, it's a service. And you look like the way we've done it in terms of the modeling is we said we have what's called a skyway network where the rooftops are the destinations, but also the recharging stations, because as we all know, the drones are resource poor. So usually your drone battery will not last more than on average around 20 minutes. So the idea there is that how you can efficiently deliver those goods in a city like Sydney, right, using the service paradigm. So the way we've done that is actually we said each segment is a service that is serviced by a drone. So that would be a service. This is the service paradigm. And the idea there is then having multiple segments is a composition. It's just a linear composition. of those services. So the idea is that what is the best composition to deliver goods from one from one place to either one place or multiple places. So again, it's all about the impact. And to me, it's just we have this very nice paradigm, this nice abstraction that could really make drones ubiquitous.
Yeah, I mean that's you described it very well with the example, and I couldn't agree more on the power of the service abstraction. So then, Rong, that brings up a very interesting challenge, right? So as Atman described, service abstraction is almost a must in these kinds of complex systems, right? But we know that with DevOps and many of the other emerging technologies, it becomes the cost of entry of people building services in many ways is lower. But at the same time, you had to handle complexities of the system, right? Like, your device capabilities, like Atman said, the amount of power it can consume, it may be resource poor. So these kinds of complex things, even though the abstraction is powerful, you described the higher level service programming language, right? Which is required to build these things. In your view, what are some of the foundational skills that we need to touch on to bridge this gap between the high-powered service abstraction and where the continuum of computing is?
Yeah, thank you, Kumar. This is a very good question. First thing, we have to understand that we are really promoting service-first approach to programming the whole system, right? Because having a whatever system to deal with all the details is actually impossible, just too complex. So I personally certainly feel that the fundamental technologies or discipline we need to teach in the universities will be a hyperconvergence of 3 core computer science kind of disciplines. I would call the 3D, right? The distributed programming language design and implementation, distributed resource management, and distributed data management. Those 3, I think, need to somehow be put together as the core of the new ways we produce services, and do that in a service-first approach with the microservice as the fundamental building block. That's I think is the only way we can somehow define high-level domain-specific programming languages for the distributed services systems.
Yeah, I mean, and so that's well said, well put. I like the combination of the programming language married with resource management and data management, and looking at it from a distributed perspective, with microservices as a way of as a unit, independently administered and sort of composed. Makes a ton of sense as to how to bring these things together. Before we go on further, let me ask Beichen or anyone else monitoring the chat, are there any questions from the audience? Okay. Yeah, well, we wait for that. So let me actually, Rong touched on this educational dimensions of, addressing the gap between the service abstraction and where the technologies are. Now, Shafee, when you look at it, and you have a very sort of a unique role, both as a teacher as well as looking at it from an institute-wide perspective. What do you see as the key factors in advancing, as you rightly described, as a transdisciplinary perspective, right, of creating the service computing, which means to me, science, engineering, technology, management, all these things coming together as you painted in your Venn diagram. So what are some of the key factors you think educators should be really focused on?
Okay, Okay, so thank you, Kumar, for your question. Yeah, so as we know that serviceology is a multidisciplinary scope, yeah, and it's a kind of bridge, yeah, between service computing, between IT and business, yeah. So if we really, we would like to cultivate the students to become the qualified professionals or elites in this domain, they need to take the knowledge from both sides, even more sides. Yeah, so from IT domain, from business management domain, from social science domain. So for us, we are experienced experts. Yeah, so it's easy for us to understand how can we teach the knowledge. But in fact, from my practical experience, it's rather difficult to teach the students in multi-disciplinary domain. Yeah, the main challenge. Yeah, so there are two main challenges. One is how to teach the students to understand the comprehensive service ecosystem and the complicated application situation from the view of multi-discipline. Yeah, this is one challenge. Another challenge is how to enable the students to study the serviceology in multi aspects rather than only in software engineering approach or IT approach. Yeah, so in multi aspects of service related science, technology, and business management in parallel and integrated ways. Yeah, so these are two challenges. I think, yeah, so for the educational program of serviceology, several key factors there are. One is the interdisciplinary advanced curriculum and the courses. Yeah, so there's some courses they are quite new. Yeah, yeah, they are across disciplinary courses. Yeah. The second factor would be the comprehensive experienced teachers from both university and the industry. This is not difficult. Normally, the professors, they adapt to teach the knowledge or theory-oriented issues. But for the service, science, and engineering, you need the experienced teachers. Yeah. So. And the third one should be a case-based study and project-based learning. Yeah. In fact, yeah. So if we talk about combination of multidiscipline, so I think projects play a key role. Yeah, rather than even more important than courses. Yeah. Yeah, because we need to ask the student to learn the interdisciplinary knowledge and experience by doing. I perform the practical projects, comprehensive practice. Yeah. And then so the fourth factor would be university industry cooperation and industry internship. Yeah. We can not only teach our students by our own, yeah, for the university. We should collaborate with the industry partners, yeah, to collaborate with them and to send our students to the practical company field. Yeah, to undertake or to engage in the real project running in the company. Yeah, so learn by practice, I think. Yeah, and the last one is the key factor is advanced platform and tools for service engineering and operations. Yeah, so we need to teach our students to apply the new advanced platform and tools. Yeah, and for so finally, for one sentence, to say the critical policy for development of such kind of program is critical to keep balance, between software service engineering and business service management, between classes and projects, between universities and industry companies, between new technologies and new business model and manners of services. Yeah, I think this is my experience and my view about how can we develop the program on service science and engineering. Quite a view. Yeah, thank you.
Yeah, Shafi, that's a sort of a rich and comprehensive view of yeah, the educational dimension of serviceology, and I completely like the idea of this case-based and project-based view, and having living labs, so to speak, like what Atman was describing about the smarter cities with swarms of drones going around in the city. It's like a living lab where you can sort of piece out the various dimensions of
Right.
serviceology. So Shahram, I had, I was just thinking through as we were hearing these different examples, and you touched on clearly the edge intelligence, even though we might have powerful abstractions to handle complex problems, service abstractions, they have to have cross-domain semantics, don't they? I mean, like what you were describing, the mixing of horizontal and vertical. And also, how do you sort of blend the different models of compute, right? I mean, where do you, like Rong touched on distributed data management. It raises a whole host of very interesting research questions. What should be the architecture? What is the underlying architecture for these evolving distributed systems, right? Where do you draw the line? What data should be in the edge? What should be in the cloud?
Right.
And how do we empower this semantic flow between domains in order to make this thing work?
Yeah, very easy questions, Kumar. Well, so my research and the research that we do in my group basically focuses on first, because what you are outlining is basically an agenda for at least 10, 20 years, right? But what we are working on is basically two main principles. One is the principle of elasticity. What I mean is similar to what Rong was describing. So the question of resources, quality, and cost need to be abstracted in like first-class citizens. So we built a language where we can describe and attach to different service abstractions the space of elasticity. So how many resources, which quality input and output, and what should the costs be? And this is one thing which we are working on, and which actually goes across these different layers or tiers rather that we were discussing. This is one important aspect. The second important aspect is what we call osmotic computing. Osmosis in a sense that dealing with, like in chemistry, from a higher resolution to a lower resolution, the molecules go. And similarly, what we would like to have is that microservices go where they are needed. So in other words, you can think of a system where there is some functionality similar to serverless computing, where the function, the service itself is actually being deployed and executed where it is required. That might be on an edge device, that might be on the cloud. And we as engineers, we would like to have a system where we don't have to specify exactly where this service actually goes, because otherwise we will not reach a higher level of automation. And this is what we are aiming for at the end. So I think that this is a huge area. We did not touch upon the area of semantics at all. We first focus on these two principles, the elasticity and the diffusion, basically. How can these services be deployed on these different tiers? So we focus, if you like, more on the engineering side and the foundational side, how this whole compute continuum can be serviced.
Yeah, I mean, you touch on two very important problems you're addressing. I mean, the whole dimension of elasticity and resilience, even within clouds, is a little bit of a struggle, especially as institutions use multiple clouds and so on, and they all have different qualities of service as we know it, right? And this osmotic computing is very intriguing. I mean, this whole dynamic management of microservices, and this idea of abstracting it from where you execute. It makes a ton of sense, and that's a very powerful notion. So that brings me, Feng, to as you were describing the service ecosystem, I like the transition that you made from, instead of looking at this as a purely technical assembly where you're looking at a service registry and then doing the service binding and doing the service oriented thing, you were sort of posing it from a value creation perspective. How does that translate into value creation, right? So this is similar to this abstraction of services. Now the question is this: as we describe all this complex service ecosystems, they all look very interesting and compelling. I mean, who could argue with them? They're all very powerful. But at the same time, we hear a lot of very interesting challenges associated with them. Either there are issues of data, who owns the data and who can share data with whom and when, or there are issues of, can you trust the information in the ecosystem, right? This basic fundamental notion of trust. How do we build that trust? I mean, that's not simply just in the technology, although technology is an important enabler, right? So I like the idea where you had the business, technology, and service all coming together with a social purpose. How do you see the service ecosystems evolving under these challenges? And what are some of the research tracks, the initial set of research issues that you think we should be looking at?
Thank you, Kumar, for your very good questions. Information integrity, cyber security, state sovereignty, and system emulation issue are all key challenges that need to be faced in development of service ecosystem. In our view, the following up research on the service ecosystem can be divided into 4 areas. The physical layer. The physical layer have widely described device and infrastructures, and these facilities can be interconnected by the IoT. Lots of sensor and actuator arranged. Physical simulation of multi-agent system as a service are focused on the research at this level. The cyber layer. The cyber layer supports the data collection, information collection, and processing, decision-making, and assignment. Software-defined technology, information integrity, XaaS service cooperation is the focus of the research at this level. The current smart city construction is at the level of data integration and evolving toward capability of integration. As for domain integration, there have been some exploration in academic such as crossover service. The social layer. For service ecosystem, users in social layer could have different social roles such as doctor, customs service, service workers, and so on. According to these social roles, user can be treated as a exhibitioner, maintainer, or even a decision maker. They can be viewed as a service consumer to submit at experience information to the cyber layer for assisting maintenance and the operation of the system. And that can also be viewed as service provider and authorized to participate in decision making to further promote system development. Complex network system research will be focused on this level of research. The non-functional requirement layer. In this service ecosystem, as a service cooperation need to be made non-functional requirement in additional functional requirement. Cybersecurity, threat, value exchange, and data sourcing issue are all in the category of non-functional requirement. Now, this field is also an emerging direction of the service ecology. And many new technologies have been introduced to solve related problems such as blockchain, federated learning, and so on. Due to the uncertainty of people and society. The evolution of service ecosystem will show complex phenomena of non-linear dynamic systems such as emerging phase change and aggregation. Thank you for listening.
Yeah, no, I think you touched on some very interesting and useful ideas that sort of bring all the things that we talked about together. It's very clear that all of us here in the panel looked at whether it's new form of services or whether new ways of producing services or even teaching services, you need abstractions. And the services abstraction is a powerful one. But Feng touched on the fact that the abstraction is not a singular thing. It's a multi-level abstraction. It's almost in a way, it's like an hyper abstraction. So, one, as Sharam said, there's an abstraction between, the service being defined and where it is executed, there is an abstraction there. And then, you have, as Rong was describing, you need a programming level software abstraction, where you have software defined higher level programming language. And then you have a domain level abstraction, much the way Atman was describing. And then, of course, you bring the social aspect and rules and regulations and guardrails to make sure that these are responsible. So it looks like we're describing a rich set of capabilities that bring all these things together. Yeah, that's fantastic. So any questions from the audience? Are there questions from panelists to other panelists? I mean, I don't need to be the only one asking questions.
Yeah, so maybe Kumar, I can ask you one question. Sure. About the trustable services. Yeah, so as I know, you concern more about the zero trust security service ecosystem development. So what's your opinion about the balance of the heavy policy for security or light check policy for the trustable service ecosystem? What's your opinion?
Yeah, so that's a both at a philosophical and a technical level there is an answer. So let me first pose the general tension between business and IT. So typically at the IT level, people want to look at vulnerabilities, look at the various ways in which an enterprise interacts with others as part of various networks, and try to reduce the risk exposure through security protocols and things like that. So that's one dimension of it. The other dimension of it is the regulatory dimension, which requires for compliance reasons to have a certain set of security and technical controls within the environment to do that. And now, usually that is viewed by people who are having business responsibilities as slowing down their ability to introduce innovation into the organization. So there's always this tussle between the security side of things and the people who want to execute business function and innovation. And that tension has manifested in many different ways, some organizationally, in the way people have worked on, and others, as we can see right in front of our eyes, that a classic example is COVID. As part of the COVID, people had to come up with vaccines in such a short time. And the only way they could do that is by collaborating and sharing data and bringing compute together and not worrying so much about the security dimensions of all of those things which would have prevented them from doing it in the past. So I don't want to dismiss that pressure as well. So, but within that context, the zero trust, Shafi, as you mentioned, is a very interesting concept that is being put forward, which is simply to say that, none of your systems, whether it's behind the firewall or outside the firewall, it doesn't matter. You invariably assume you cannot trust it. And then you design your protocols, your processes, the way you process data, all of that in a way that would validate and verify the trust before you execute. And that manifests in so many different technologies. One of the technologies which is coming up quite with rapid adoption is this thing called confidential computing, which sort of plays into this idea of not just having a general operational assurance of trust, but can you technically verify trust? And it manifests all the way from silicon in the hardware, where you have secure enclaves, where you can protect the data and protect the processes that run the data, to the next level up above that, where within the containers you can make sure that the containers have the images of the containers that you are initiating, they are properly signed and can be authenticated, and at runtime you can attest that image, so that you have technical assurance and guarantee that you are actually running the code you intended to run. And then on top of that, you have business controls and technical controls which are aligned. So you could set up policies, higher level policies, that are then mapped into these technical controls. So I think software is coming up, and and as Rong mentioned, there's a lot of complexities and rough edges, and which needs to be solved. And I think the services paradigm actually gives us a lot of hope to address this. And there are very interesting, and I like, Shafi, I like your idea of using case studies and real project-based things to motivate these topics, right? So if you look at information supply chains, exactly to your question as to how do you address trust there?
Yeah. Thank you. Very good answer.
Any other questions?
Can I expand on what you said, Kumar? I think this is a very important, crucial question when it comes to trust. So, the fact that you're gonna make a lot of the resources, whether it's the IoT or the cloud, as services, I think it's one issue that is almost orthogonal is the trust issue, because it applies to everything. So, and if you add the fact that you may be getting those services from unknown parties, right? Untrusted parties, like in crowd sharing, like the Uber now, right? Airbnb. So you are renting a room. You are getting a car from making a reservation with people that you've never seen, that are not being vouched by anybody, right? So it poses a fundamental issue, and that is, how can you trust these services? And to me, it's the whole point of going into that model is we don't want to have a centralized view of the world, right? Because it's a bottleneck. And I agree that actually in many circumstances, it does stifle innovation, right? Instead of going to your known taxi driver, which actually you have to pay much more, you're actually willing to give up some of the security that you have, the fact that this person has been vouched for, to a much cheaper and more available, like Uber, for instance. And to me, this is really, but then you still have to have some kind of trust in place to be able to say, well, why should I trust this Uber driver, right? And not another one, because I have a choice now, right? So to me, this is very important. It's not the trust in itself, we shouldn't really put it in terms of whether we want to go centralized or not. We already made that decision. We don't want centralized. We don't want more rules, more regulations. Because why? Because we want convenience, we want cheaper, we want more available, we want, all these things that are very important to us. But then we say, well, yeah, I don't want centralized, but I still want trust.
Yeah.
Right, and that's really what the question. I don't want it centralized, but I want trust. But and as you said, Kumar, it's a complex question, right? It's not. But to me, yeah. So anyway.
No, you said it so well. I mean, and I think it's very important that we, as we look at powerful service abstractions, the trust issue be also looked at, right? That even, as you said, it's orthogonal to it, but very integral to it, nevertheless, right? So I think, looking at models of trust and which ones are enabled by the evolving distributed systems and distributed services and distributed service paradigms, right? How do you do that? And how does this thing operate at scale with the resilience that is needed? And the notion of resilience and trust also go together, right? Especially in light of, very hard problems and challenges like the impact of climate, for instance. And so, yeah, I totally agree with you. I mean, this is a very interesting research topic.
Yeah, Kumar, I just want to add one thing. That is the fact that the importance of consumability has often been underestimated from the viewpoint of the consumer as well as from the provider. So when we have the technology innovation in many places and evolve very rapidly, the consumability of putting all the tech together become another big challenge for us right now.
Yeah, no, without question. I mean, consumability at so many levels, right, wrong. So even at the systems level, at the DevOps level,
yeah,
even at the experience level of individual users who are consuming the services, right? And how do you project the right experience? And this is something that people are all very consumed by, and looking at different ways of doing it. So yeah, I agree. Lots of fascinating topics. Any question at all from any of the folks in the audience, Beichen? Maybe we kept them busy with the exciting set of things. So let's, I'm looking at the time. We are almost 3 minutes to wrap this up. I just wanted to put this up here as a summary of many of the things we talked about. It doesn't capture many of the exciting things we discussed in the Q&A and in the panel. But just to make the point, starting in the middle, and then going up and down. So, one is, it's very clear that as we look ahead and look at any kind of serious problems that the world faces, we are looking at new forms of services and new types of service ecosystems. And these are actually manifesting the transformation that is happening right in front of us, digitally, both industrial, economic, various social transformations. They are manifested in these services and service ecosystems. And it's very clear, as all of our distinguished panelists have talked about, that this innovation will be very likely encapsulated in everything as a service. And in many ways, as we're talking about intelligence that is getting distributed, and we are looking at the emergence of a next generation internet and intelligence services, what we really need to understand is, as Sharam put it, we need to be mastering the evolution of computing to make this happen. And it needs to actually bring together in a harmonious way, cloud and edge and the cloudy edge and edgy cloud and the fog in between and all of that. All of those compute architectures has to be brought together. And service abstractions, even at that level, as intelligence gets more and more infused into the infrastructure, and as Shafe pointed out, there is an alphabet of technologies that are coming here that are all have to come together. We need to have service abstractions to actually manage that complexity and bring it together in a cohesive way. And that would, again, you would see that through distributed service programming languages that capture powerful abstractions, as Ron was describing. You need definitely collaborative and edge intelligence to address problems, as Atman was describing, for the drones and the energy services for IoT, and how all of these capabilities have to be put in the context of value and being value driven and value based. That's what's going to make it different. We're not doing the services just for the fun of it, just for the technical aspect of it, although that in itself is very interesting. It needs to address the value-based social concerns, and that in turn, it would require us to look at this in not only as multidisciplinary and interdisciplinary, but as Shafe put it very eloquently, it's transdisciplinary, and this is really a scientific foundation. And so for those folks who are listening and who are actually advancing the R&D in this space, the onus is on all of us to actually build up the scientific foundation of services computing. And it's a really exciting time for this entire field. And I actually want to thank this really distinguished panelists to touch on so eloquently the various dimensions and the multifaceted aspect of services computing, both the new forms of services, new ways of producing services, as well as the new education programs that are needed to bring up the talent to address this.
Thank you very much, Kumar, for this excellent summary. Really, very good summary.
Yeah, thank you, Kumar.
Thank you, Kumar.
Thanks,
everybody.
everyone.
It was great. Bye-bye.
Thank you very much. Thank you again.
Bye. Stay safe. Bye.
Bye-bye.
Thank you. Bye.
Salam, see you tomorrow. Yeah. Okay. So very enjoyable and meaningful panel. Thank you.
Thank you. Bye.
Bye.
Bye.